Continuity and differentiability. If the following function is continuous at x equal to 0, then find the value of k. We are given function fx, which is equal to 1 minus cos 2x divided by 2x square when x does not equal to 0, and it is k when x equal to 0. So from here, we can find LHL and RHL. So LHL, limit x tends to 0 minus, and we write the function. So 1 minus cos 2x divided by 2x square. And we know that cos 2 theta is 1 minus 2 sine square theta, or 1 minus cos 2 theta equal to 2 sine square theta. So here we write limit x tends to 0 minus, and instead of 1 minus cos 2x, we write 2 sine square x divided by 2x square. So 2 will cancel out, and we know that sine x upon x is 1. We can write it limit x tends to 0 minus sine x upon x whole square, and that will become 1. If we write RHL, everything will remain same. In place of 0 minus, we have to write 0 plus, and nothing will change, and value will be 1. Since LHL equal to 1, RHL equal to 1, and value of function at x equal to 0 is k, so function is continuous, so we can say that k equal to 1. So this is our required answer. Now let's go to next question. For what value of k the function is continuous at x equal to 0? This is similar question as we have done in question 1. The same process is to be adopted. So 1 minus cos 4x will become 2 sine square 2x, because remember cos 2x equal to 1 minus 2 sine square x. If you make this angle 4x, then it will become cos 4x. It will become 1 minus 2 sine square 2x, from where one can get 2 sine square 2x equal to 1 minus cos 4x. So for LHL and RHL purpose, we have to take this value. So LHL, limit x tends to 0 minus, and function is 1 minus cos 4x upon 8x square, and then we put the values. Limit x tends to 0 minus, and this becomes 2 sine square 2x divided by 8x square. This will become 4. So limit x tends to 0 minus, and we can make it 1 sine 2x divided by 2x whole square multiplied by 2x whole square divided by 4x square is already given. So this will become 1, and this will become 4x square. This will also become 1. So if we find RHL, same process is to be adopted, except 0 minus will be replaced by 0 plus, and other things will remain same. So value we will get as 1. Since function is continuous, so LHL equal to RHL equal to value of function. So f at 0. So we will get 1 equal to k. Now let's go to next question. Given that fx equal to 1 minus cos 4x divided by x square when x is less than 0, it is a when x equal to 0, and it is root x divided by root 16 plus root x minus 4 when x is greater than 0, and function is continuous at x equal to 0, then we have to find out what is a. So let's proceed. For LHL purpose, we will use this function. So LHL, limit x tends to 0 minus 1 minus cos 4x divided by x square. But 1 minus cos 4x will become 2 sine square 2x. So limit x tends to 0 minus 2 sine square 2x divided by x square. So we can write it, limit x tends to 0 minus 2, then sine 2x divided by 2x whole square multiplied by 2x whole square divided by x square. So we simplify it. So from here, this will become 1 and this will become 4x squared divided by x square. X square will cancel out 4 and 2. So 2 into 4, that is 8. So we have got LHL. Now the value of A must be LHL, which must also be equal to RHL. So we have got the value of A as 8, but let's check it by RHL also. So RHL. So it is given limit x tends to 0 plus. Then we write the function root x divided by root 16 plus root x minus 4. So what we can do is to rationalize the denominator. So it will become a limit x tends to 0 plus root x times root 16 plus root x plus 4 divided by, here if we multiply by root 16 plus root x plus 4 to this number, so we will get 16 plus root x minus 16. So 16 will cancel out, root x will be left, and that will cancel this root x. So now we are left with limit x tends to 0 plus root 16 plus root x plus 4. Now we can put the value of x as 0. When we put x equal to 0 here, then we will be left with root 16 plus root plus 4. So root 16 is 4 and this is also 4. So we can say we get value of RHL as 8. LHL is 8, RHL is 8, and value of function at x equal to 0 is 8, which means a equal to 8. So we have got the answer. Now let's go to next question. We are given that this function is continuous at x equal to 0. We have to find out ABC. Let's see how. So here x is less than 0 means LHL. So we consider LHL, limit x tends to 0 minus, we write the function sine a plus 1x plus sine x divided by x. Now we will try to make this as 1, this as 1. So x tends to 0 minus, this will become sine a plus 1 times x divided by a plus 1 times x into a plus 1 times x plus sine x upon x times x whole divided by x. So this will become 1, this will become 1. So we will be left with a plus 1 times x plus x. So limit x tends to 0 minus a plus 1 times x plus x whole divided by x. So x, if we take common, then it will get cancelled by this x. So we will be left with a plus 2. Now this is equal to C, means value of function is C, so a plus 2 equal to C. But let's consider RHL also. So we have got this value as a plus 2. LHL is a plus 2 and value of function is given as f0 is given as C. Now RHL. For RHL, we write limit x tends to 0 plus, and we write the function x plus bx square with under root minus root x divided by bx power 3 by 2. We rationalize the numerator, so we multiply root x plus bx square plus root x divided by root x plus bx square plus root x. So what do we get? Limit x tends to 0 plus. So here this root will get cancelled. So x plus bx square minus x divided by bx power 3 by 2 times the root of x plus bx square plus root x. Now from here x will get cancelled, and if we take out root x from here, so what will it become? Limit x tends to 0 plus bx square divided by b times x power 3 by 2, and from here we are taking a root x common, so root x common, then we will be left with inside the root 1 plus bx plus 1. Now x power 3 by 2 and root x will become x square, from where this term and this term will get cancelled. B will also get cancelled. So in numerator, 1 will be left. In denominator, root of 1 plus bx plus 1 is left. When we put x equal to 0, then this term will also vanish. Then we will get root 1 plus 1, that is 2. So RHL we have got as 2. So we have three things: LHL a plus 2, RHL is just 2, and value function is C. All three must be equal. So let's equate these two. A plus 2 equal to 2. So that will give A equal to 0. And then from here, LHL equal to RHL equal to value of function. So since LHL is a plus 2, but RHL is 2. So we can say that C is also 2. And B is not occurring in our calculation. It means we can have any arbitrary value. Let's see next question. Find the value of a for which the function f is continuous at x equal to 0. We are given the function a sine pi by 2 x plus 1 when x is less than 0 or equal to 0, and tan x minus sine x divided by x cube when x is greater than 0. So let's see. So for this purpose, we find LHL. Limit x tends to 0 minus, we write this function, a sine pi by 2 x plus 1. So here, if we put x equal to 0, so on putting x equal to 0, what do we get? it will become a sine pi by 2. So that is just a, and value of function is also same. So that will remain a. Now consider RHL. Limit x tends to 0 plus. We write this function tan x minus sine x divided by x cube. So what we do, we take out sine x from here. Tan x equal to sine x upon cos x. Sine x can be taken common. So limit x tends to 0 plus, we take sine x common, 1 upon cos x minus 1 divided by x cube. X cube. Now let's write it further, which is equal to limit x tends to 0 plus sine x times 1 minus cos x divided by cos x times x cube. And 1 minus cos x can be written as 2 sine square x by 2. So limit x tends to 0 plus sine x times 2 sine square x by 2 divided by cos x times x cube. Now we have to make these terms 1. So for that purpose, we write limit x tends to 0 plus sine x upon x times x into 2 sine x by 2 divided by x by 2 whole square times x square by 4 whole divided by cos x times x cube. Now this will become 1, this term will become 1. So, and this will divide this 4, so we will be getting 2. So x cube divided by, we get limit x tends to 0 plus x cube divided by 2 cos x times x cube. So let's write it further. So RHL, where we have got limit x tends to 0 plus and x cube divided by twice of cos x times x cube. So x cube will cancel out 1 upon 2 cos x. And now we have to put value of x as 0. So we get 1 upon 2 into 1, that is 1 upon 2. Since function is continuous, so all values like LHL and RHL must be equal. So since LHL is A and RHL is 1 by 2, so they both will be equal. So we get A equal to half, which is our answer. Thank you for watching.